Hello everybody, welcome to another calculus video on Thomas's calculus. Today we are going to look at chapter 5.5, integration by substitution. To integrate by substitution, you have to know the differentiation and of functions and the integration of functions. So let's say if fx is the function, we will look at differentiating a function dfx over dx, and we'll also look at integration of functions, which is integral fx dx. So if we are given a function x to the power n, if that's your function, fx is equal to x to the power n, differentiation would be n times x n minus 1, while integration would be, we know integration of x to the power n would be add 1 to the power and divide it by that power, and it's called the power rule. So Vx is n plus 1, add 1 to the power and divide it by the power n plus 1 plus c. So let's use this on some examples. We'll start with the easiest. Let's do x to the power 2. So x to the power 2, now n is 2 here, fx equals x to the power 2. Differentiation would be you multiply by the power, that is 2x, and subtract 1. So 2 minus 1 is 1, x to the power 1 is x, so we get 2x. And integration, what you do is add 1 to the power, so 2 plus 1 is 3, x to the power 3, divided by the same power 3 plus a constant. We know when we integrate we add a constant there. So next thing, let's look at the next function. Let's do fx equals 1 over x squared. So this is equal to x minus 2. So if x to the power minus 2, what we do here is n is equal to minus 2 in this equation over here. So we multiply it by minus 2, then x, and then subtract 1. So 2 minus 2 minus 1 is equal to minus 3. So it is equivalent to x to the power, it's minus 2 x to the power minus 3, or it's equal to minus 2 over x to the power 3. So when it comes to integration, what we do is add 1 to this, which is equal to x, let's add 1 to it, so x to the power minus 2 plus 1 and divide it by that power. So that is minus 2 plus 1 is minus 1. Let's write it down, 2 plus 1. So that is equivalent to x to the power minus 1 over minus 1. That is equal to minus 1 over x. That's the integration of x to the power 2. Let's look at some other examples. Let's look at the function fx equals x to the power half. Now n is equal to half, so what we do is when you're differentiating it, you multiply by the power and subtract 1. So x half minus 1, that's minus half there. So we get half x minus half, which is equal to half square root of x. Now if we want to integrate it, you add 1. So it is x to the power half is your function, add 1 to that and divide it by half plus 1 and plus c. That's a constant. So this is, so let me do this in a different color. Let's do it in red. So half plus 1 is equal to, maybe I should delete this, is equal to 2, 1 plus 2. That's 3. 3 over 2. So we substitute it back. So we have x 3 over 2 divided by 3 over 2. So this would be 2 over 3 x to the power 3 over 2. So you might wonder why this is 3 over 2. Let me use a different color to explain that. So if we take what we say here is, this would mean x to the power 3 over 2 divided by 3 over 2. Generally, when you convert division to multiplication, you switch this. So it would be x to the power 3 over 2 multiplied by 2 over 3. So that's what we get. So divide by 3 over 2 is equal to multiply by, you get the reciprocal of that, 2 over 3. So that's what we have here. So let me take the next function. Let me say, so we should also add c here. Let me take the function x to the power minus half. Take x to the power minus half. So when you are taking the derivative, you multiply by minus half, x to the power minus half minus 1. So that is minus 1 over 2, x to the power minus 3 over 2. So for integration, what we do here is we take x to the power, that's your function, minus 2, add 1 and divide it by minus half plus 1. So we know minus half plus 1 is equal to half. So we get, and plus c, so we get x to the power half divided by half. You know divided by half is equal to multiply by 2. So it's 2x to the power half. Let me do a few more questions. We'll do I'll name some functions to get the derivative and the integral of that. So that's plus c, don't forget the c. Next, let's look at the function fx equals 1 over x. So 1 over x can be written as x to the power 1. We use the power rule here for differentiation. So we take the power and multiply it by the power minus x and we subtract 1. So minus 1 is equal to minus 1 x to the power minus 2. So this is minus 1 over x squared. That's the differentiation. Now integration of 1 over x, we know that it is ln x, and this is something you must remember, ln x plus c. Integration of 1 over x is ln plus c. So let's look at the integration of ln x. So ln x, when you differentiate it, you get 1 over x, but when you integrate it, it is not that straightforward. So we are not going to write anything, but it is not straightforward to integrate ln x. You will see that you have to use it, use 1 as a function and multiply it by ln x to get the integration. For the time being, I'll write the answer here, but when you integrate ln x, you get ln x minus x plus c. So that's the answer, but we will look at how to integrate and get this answer later. So let's look at some other functions like sin x. Sin x, we know that the differentiation is cos x and integration is minus cos x plus c. Let's look at sin k times x, kx, k times x. The differentiation would be k times cos kx while integration would be minus, we take the value here k and we divide it by k, and we still have cos kx plus c. Let me draw a line here separating that out. So we'll draw a line here as well. So if we'll do cos x here, cos kx. Now cos, when you differentiate it, we know that it is k sin x minus k sin kx. But when you integrate it, what we do is we get positive 1 over k sin kx plus c. We'll do a few more examples. Next, let's look at something easy. E to the power x. E to the power x. When you differentiate it, you get e to the power x. When you integrate it, you get e to the power x. But e to the power kx is a little tricky. When you differentiate it, you get k e to the power kx. When you integrate it, you get e to the power kx divided by k. Now let's look at this function. So as we look at this, we see it's a function multiplied by function. So it's a function of this nature, fx multiplied by gx dx. To integrate function multiplicative functions, there are two ways of doing it. One way is by substitution. So if you inspect this well, if we say fx or u is equal to x cubed plus x. Let's take fx to be that, or u fx to be this, or u to be equal to this. Then when you look at this function, you'll see that this function 3x squared plus 1 is, you get that function when you differentiate this. In other words, we see quickly that du over dx is equal to 3x squared plus 1. So now this should tell you that we should use u as this function because its derivative is hidden within a function, within the function. So if we have two functions and the second function is the derivative or function of the derivative of the first function, we use substitution. So in this case, we use the smart thing would be to use u as this function and then get the derivative. So the purpose of this is to take two functions and convert it to a function of this nature, a function of hx dx or hu du, some function, a single function that you could integrate, because you cannot integrate multiplicative functions. So we want to convert this to a function of this nature. So to convert it to a function of this nature, we need to substitute for dx and we need to get this function out of the way. So this function over here, if we call this u, we need to get this underlined in light blue out of the way. So let's do, if you call u equals x cubed plus 3, then we know du over dx is 3x squared plus 1. Then let's take the dx to the other side. So we'll do a small trick here. So du equals 3x squared plus 1 dx. And now quickly we see this is the same thing as I underlined here. So that's the same thing here. So let's let me tag the two so that you can see that's the same thing here. And then we go and substitute the u. So we see integral. We saw that this is u, so it's u to the power 5. And simply this 3x squared plus 1 is also du. So now we have come to this function. Now we have this right here, function, just one function. That's what we have to do, just one function. And we know how to integrate this. Integration of this is you add 1 to the power, so it's 6 over 6 plus c. And it's u not x, it's u not x. So maybe I should rewrite that. It's a u not x, u. So then we substitute it back. We put the u here. U is equal to x to the power 3 plus x to the power 6 over 6 plus c. So that's the answer of the question. So when you see two functions of this, if you see that one is a derivative of the other, the one that is a derivative, you take that function as u, so that when you differentiate it, you can categorize both these functions, both these as the derivative or as du. So we take that and try to call that as du. So we have that as du and this function as hu. That is the sole purpose of substitution, and you can do the substitution when you have this where one function is a derivative of the other. So you need to always think of what is a derivative of the other. So the function that you take the function as u, and then you do the derivative of that and then call that as du. Okay, let's do another question. So let's look at this function. So we see clearly there is one function here, and there is another function here. So that is, it's like fx multiplied by gx dx. So if we look at gx specifically, gx is square root of 2x plus 1, but we look at just the 2x plus 1. We see that when you differentiate 2x plus 1, we get the x there. It should be 2x. It should be 2, but you can get rid of this if you substitute it as u. So let's start by substituting u as 2x plus 1. If you do that, we know we'll differentiate it that du over dx is equal to 2. So we have the 2 here. Next thing, we still do not have a way to get rid of x, but we can use this function to derive what x is, to see what x is. So with this, we'll try to do u minus 1 is equal to 2x, and x would be equal to u minus 1 over 2. So now we have dx. Let me do one more thing here. Dx is equal to du over 2, and we have u and we have x, so that we can make this a function of u. So what we want to do is to make it a function of u. So let's do this here. So we'll differentiate it. Substitute it. So we have integration u minus 1 over 2, and this is u to the square root of 2, or u to the power half. And we have dx is this. Dx is du over 2. So now it's a little complicated here. So what we'll do is we'll take this is equal to 1 over 4 integral u minus 1 u to the power half du. Now we'll multiply. When you multiply, you add the powers. So 1 over 4 integral u1 multiplied by u half would give, you add the powers, 1 plus half is 3 over 2 minus u half du. Now we know how to do this because it's just simply the power rule. So what do we do for the power rule? We add 1, so we'll write that down, u 3 over 2 plus 1 divided by 3 over 2 plus 1, then minus u half plus 1 divided by half plus 1 plus c. So let me do this in a different color. So 3 over 2 plus 1 is equal to 2. 3 plus 2 is equal to 5 over 2. And then the second part, we know half plus 1 is equal to 3 over 2. So I'll get back to this question. So that is u to the power 5 over 2 divided by 5 over 2 plus u to the power 3 over 2 divided by 3 over 2 plus c. Let me do this in the next page. So I've copied this from the other page where u is equal to 2x plus 1. So u 5 over 2, u 3 over 2 divided by 5 over 2, and we saw plus c, not 1, plus c. So this is equal to u, we have a 1/4 also here, 1/4 of that. So we bring the 1/4 down again. So u 5 over 2, and we have 2 over 5 plus u 3 over 2 times 2 over 3. So when you multiply this, you get 1 over, when you multiply that, 1 over 10 u to the power 5 over 2 plus, was it plus or minus? Oh, it was minus, not plus, it was minus. So I'm going to bring this here. It was minus, minus, minus 1 over 6 u 3 over 2 plus c. So that would, still it's not the answer. We had to get it back to x's. So we get 1 over 2. We multiply 2x plus 1 to the power 5 over 2 minus 1 over 6. 2x plus 1 over 3 over 2 plus 6. Let's do one more question. So this is finding the integral of square root of 2x plus 1. So one thing we can do here is similar to what we did previously. We use u equals 2x plus 1 because we know the integral of u to the power half. That is, we do know the integral of u du. We know the integral. So if we could convert this to something like this, we should be able to integrate it. That's the purpose of substitution. So, but we do have a dx we have to get rid of. So we will differentiate this du over dx. Now the purpose is to substitute dx to find a function of with respect to dx, or we differentiate with respect to dx so that we could find a function to substitute for dx. So when you do that, we get 2. So we now have dx is equal to du over 2. So now we have a function for this, we have a function for this. So we are getting close to what we want to find here. So let's rewrite this. So we'll write integral square root of, this is u, and dx is du over 2. So this is not a function of x u, so we can bring it forward. So we can write it half integral u square root of u du. And this is something we know how to do. So let me rewrite this. So we have this as half integral u to the power half du. So we will go here. Now we'll give enough space. So it is half, if you integrate this, we know what to integrate, how to integrate this. We add 1 to the power half plus 1 divided by half plus 1, and we add a c here. So it is half u 3 over 2 plus c, and this is half u 3 over 2 times 2 over 3 plus c. So we can now cross these off. So we'll have u to the power 3 over 2 divided by 3 plus c. And we never keep it in terms of u, we have to substitute it in terms of x. So we get 1/3 2x plus 1 to the power 3 over 2 plus c. Let's do one more example. So let's look at this function. Now we know the integral of, let me change the color of the pen. We know the integral of cos u. Cos u. We know the integral of cos u du. So what we want to do is convert this to this form. That's our purpose. So if we take u as 7 theta plus 3, then we have du over d theta is equal to 7. So now we can get d theta equals du over 7. So if we substitute this and this to this equation right there, we will see integral cos, and we have u here, and d theta is du over 7. So because 7 is not a function of u, we can take it outside the integral function. So we have cos u du, and we know how to integrate cos u du. Cos u du is sine, we know that. So we have sine u plus c, and we do not keep it like this, we have to substitute the u. So we have to give it in terms of a theta. So we have 1 sine theta u is equal to 7 theta plus 3 plus c. So that's the answer. Let's do one more question. So if we look at this question, we see that it is of function fx times gx format. And if we investigate it a little further, we'll see that a differentiation of x to the power 3 d over dx, so the x to the power 3 is equal to 3x squared. So we see that the derivative is hidden in this as well. So this is the derivative that's hidden in this as well. So now we know that the function u should be, let me erase that. So we know that function u should be x to the power 3, because the derivative is also within the function. So du over dx is equal to 3x squared. Now, if we can substitute for x squared and dx, a function of u, we should be able to get this function in the form of hu du that could be integrable. It could be integrated. So let's do this. So we have dx is equal to, let's keep x squared on this side and we'll get the 3 down here should be x squared dx. So we know x squared dx is already here. So x squared dx is here. So we can substitute that in terms of u. So we have, if we substitute u, e to the power x cubed is u, and dx, x squared dx is du over 3. Now we know how to integrate this, so there you go. So we have 1/3 integral e to the power u du, and we know e to the power u du is equal to ex. So we have 1 e to the power u, eu, plus c. So we do not keep it like this. We have to substitute it, substitute the u back in terms of x. So it's e to the power x cubed plus c. So that's the answer. Let's do one more question. So if we investigate this function, it is more like a function of fx over gx dx dz really. So we say z, z and z dz. But if you investigate it closely enough, we see that z squared plus 1, if we get d over dz, is equal to 2z. That's a differentiation of this function. And we see that 2z is fx. That's equal to fx, because that's 2z is right here as well. That's equal to 2z. So for this function, we will take u equal to z squared plus 1. So du over dz would be 2z, and then if we take 2z, if we can take 2z and substitute that in terms of u, we would get 2z dz is equal to du. So now we have a function, this function in terms of u, and we have gx in terms of u as well. So we are ready to substitute it. So we get integral. So we take this here, right? So we have 2z dz is equal to du, and 1 over of u cube root of u. So let's take this as, we simplify this as u to the power minus 1 over 3 du. Let me do one more step before that. So this is equal to integral 1 over u to the power 1/3 du, and that's equal to 1 over 3rd to the power minus 1. So when you're integrating, you add 1 and divide it by that power. So minus 1/3 plus 1 divided by 1/3 minus 1/3 plus 1. So it is u to the power 2 over 3, because 1/3 plus 1, I'll do that on a side. minus 1/3 plus 1 is equal to, the common denominator is 3, minus 1 plus 3. That is equal to 2/3. So that is 2/3. That's how we got 2/3. So we have 2/3 over 2/3 plus C. So this is equal to 3/2 u 2/3 plus C. We do not keep it in terms of u, we have to substitute it back. So it's 3/2 and z squared plus 1, 2/3 plus C. That's the answer. Let's do one more question. So what I want you to do is work through these 3 problems, pause the video and do the problems and come back and see whether you did it correctly. So now I will take a few minutes and help you do these questions. So in this question we see that if to convert this to a function of u du, integral function of du, if we take u equals 2x plus 4, we know that du over dx is equal to 2. So we can substitute, so that will give us dx equals du over 2. So now we would be left with a function, integrable function, that is 2 u to the power 5 and dx would be du over 2, and these would cancel off. So we would have u to the power 5 du, and you know how to do that. So let's look at the next function. Next function would be to make this a function of fu du that can be integrated. So we take 7x plus 1, minus 1 as u. So du over dx is equal to 7, and you can easily make this into a function of u. You can make that into a function of u. Now this is a little tricky. We see that there is a 2x here, so ideally we want 2x and dx to be du. So, and we see that as the opportunity if we use u equals x squared plus 5. If u equals x squared plus 5, du over dx is equal to 2x. So in other words, du is equal to 2x dx. So this is the function here. So if we substitute it back, we will see integral 2x dx would be du. We take that as du, and that's your function du. And then we have u to the power minus 4, and we know how to integrate that. We do a few more questions. I would again like you to pause the video and see what functions could be used as u in these cases, and then after you complete the integration, come back and check the answers. So here we see this is a form of integral fx over gx, and we see that if you take x to the power 4 plus 1, we see differentiation of that dx would give you 4x to the power 3, and that is this function. So the way to go here is, let me erase this. So what we do here is we take u equals x to the power 4 plus 1, and then du over dx is equal to 4 to the power x squared. So if you then du is equal to 4x to the power cubed, not squared, cubed dx. So there you go. So we have found these two to be equal to u. So by substituting u equals x to the power 2, we can get a function of f integral f u du to integrate that. So the next question, we did something similar to this, and here we see that if you take this function and differentiate that, you get a form of this function. So let's look at u equals 3x squared plus 4x. So du over dx is equal to 6x plus 4, and this is equal to 2 times this function, 2 times 3x plus 2, so which is also this function. So now we will say, I'll do it a little further. So du is equal to 2 times 3x plus 2 dx. So we have the 3x plus 2 dx here. Maybe I should write it as two functions here, 3x plus dx. So that means we have a function, we can, if you substitute it back, we have a function du that can be integrated, because it's one function, not two functions. So that's what we do. So for this question, you can do the rest by yourself and complete the integration. So for this, if we take u equals 1 plus square root of u equals 1 plus square root of x, then du over dx would be equal to half x half minus 1, so it would be half square root of x. So that implies du is equal to dx over 2 square root of x. So now we see that dx square root of x, let me do this, dx square root of x has been can be substituted by 2 du equals dx over square root of x. So this can be written as a function of u. Let me write that, and then you can integrate it. So u to the power 1/3, you take the 2 outside, and du, and this can be integrated very easily. So that's it for now. Next I'll do the product rule for integration in the next video.